All right, let's look at some related rates problems. Let's look first at this cylinder problem. A right circular cylinder of a constant volume is being flattened. At the moment, when its radius is 3 centimeters, the height is 4 centimeters, and the height is decreasing at a rate of 0.2 centimeters per second. At that moment, what is the rate of change? So the first thing I'm going to do is write down all of my given information. And then I'm going to identify what I'm trying to solve for. It says, what is the rate of change of the radius? So that's dr over dt. Now, the first thing I'm going to do is write the formula. The volume of a cylinder is V equals pi r squared times the height. And now I can take the derivative of it. Well, first of all, when I go to take the derivative of V, since it's a constant volume, the derivative of a constant is 0. Now over here, what I'm going to do, because there's a coefficient of pi, I'm going to factor that out. And now I'm going to take the derivative of r squared times h. Well, that involves using the product rule. Remember, the product rule is f prime g plus fg prime. So if I take the derivative of my f prime, which is r squared, that would be 2r times dh over dt. Times h plus f, which is r squared, times the derivative of h is 1 times dh over dt. Now from here, I just plug in all of my given information. Now I can simplify. I plugged in my radius is 3, my height is 4, and my dh over dt is negative 0.2 centimeters per second. Now I can actually algebraically solve for dr over dt. So I'm going to next simplify. And now from here, I can distribute the pi. Add the negative 1.8 pi to the right-hand side. Cancel out the pi since it's pi divided by pi. And so therefore, if I plug in 1.8 divided by 24 into my calculator, I get 0.075 centimeters per second. So the first thing I'm going to do is write down all of my given information. Then we can write down what we're trying to find. Since we're trying to find out how fast the height is increasing, that would be dh over dt. We'll notice in all of the given information and what we're trying to find, the radius is never mentioned. Well, there's a reason for that, okay? The height is equal to the diameter. Therefore, what I can do is I can write the radius in terms of the height. Remember that the diameter is equal to 2 times the radius. Well, if I know that the height is equal to the diameter, then I can say h is also equal to 2 times r. And therefore, I can get the radius by itself by saying height divided by 2 is equivalent to r. This information will be necessary whenever we go to write down the volume formula of a cone. The volume formula of a cone is V equals 1/3 pi r squared times the height. Again, I would not want to take the derivative right now because nothing in my given information, nor what I'm trying to find, talks about the radius. The first thing I want to do is substitute in the fact that the radius is equal to h divided by 2. Now from here, I want to algebraically simplify. I can distribute that squared. And now I can clean this up by using exponent rules and then multiplying fraction by fraction. So therefore, this becomes pi over 12 times h cubed. Now I can go ahead and take the derivative of this problem. The derivative of v is, of course, dv over dt. Pi over 12, if we take the derivative of h cubed, well, the derivative would be 3h squared because of the power rule, times dh over dt. So if we clean this up, this would be dv over dt equals 3 over 12 reduces to pi over 4, h squared times dh over dt. All right, and now we can plug in everything that we know. All right, and when I plug it in, my height is 8 since the height and diameter are the same, and we knew the diameter was 8. And now if we simplify, we have 2 equals pi over 4 times 64 times dh over dt. 64 divided by 4 is 16. So we have 16 pi times dh over dt. And now if I divide off the 16 pi, I have 2 over 16 pi, which reduces to 1 over 8 pi. And this is height, so that would be meters per second.